So today we'll be looking at Norton's theorem, and the question here is asking us to use Norton's theorem to find the current passing through the 3 ohms resistance. And in using Norton's theorem to find current passing through a particular resistor, you have to know your Norton's current IN and our Norton resistance RTH. Now let's redraw our circuit diagram. So we have our 42 voltage source, so this is our 12 ohms, our 6 ohms, and our Norton current IN. Now, since now the current is being produced by 42 voltage going this way, so when you get to this node, it will divide itself into two, of which one is the Norton current. So let me represent the one that will pass through here with I1. Now we know that the main current that will be going through the circuit is going to be I1 plus IN. Now let's use KVL to solve for the values of I1 and IN. Now from the first loop, we have 42 is equal to 12 into bracket I1 plus IN plus 6I1, which is going to give us 18 I1 plus 12 IN 42. Now we have equation 1. From the second equation, we can have this equal to 6I1. Solving for I1, we'll have 35 over 6 amp. Substituting the value of I1 into equation 1, we are going to have 42 equal to 18 into bracket 35 over 6 plus 12 IN. So In is now equal to 1 on 12 to bracket 42 minus 105, which is going to give us minus 21 on 4 amperes. Now, since we know our In, let's find our RTH. In finding the RTH, we have to deactivate all the open sources in the circuit. So now we have to short circuit all the voltage sources and replace the In by RTH. So let's draw the circuit diagram again. We are going to have this. We have 12 ohms here, 6 ohms here, and our RTH. Now, the 12 ohms is parallel to the 6 ohms. 12 ohms is parallel to the 6 ohms. Now we are going to have the RTH is going to be 12 times 6 over 12 plus 6. So which is going to give us 4 ohms. Now since we know our In and our RTH, we can represent the In and the RTH on a circuit diagram. Now we have this. Our In, this is our RTH. The RTH is the same as Rn. Same thing. Okay. And we have our 3 ohms here. The resistor that we will find the current that was passing through. Now we are going to use a current division rule to solve for the current passing through the 3 Newton. And the rule states that if I have two resistors in parallel and there is a main source coming, the the resistor that I want to find the current for is equal to the other resistor over the total resistance in the time the total current coming. So we are going to have I, which is equal to the current passing through the 3 ohms resistor, is now equal to the RTH over the total resistance in here, which is RTH plus 3 times the total current which is coming, which is the IN. Now we know our RTH to be 4 and our IN to be negative 21 on 4. Yeah, negative 21 on 4. When you input this inside the calculator, you're going to have negative 3 amp. So there's a current of 3 ampere passing through the 3 ohms resistor. Thank you.